So today you're doing 3.8.1, which is imaginary numbers. So we've already kind of talked about the fact that you cannot take the square root of a negative number because it gives you no real solution. Okay? But there are imaginary numbers that were invented just for this purpose. Okay? And the reason they were invented is because the fundamental theorem of algebra says that whatever exponent you have there is how many roots there are, or how many times some function crosses the x-axis. So if you have a squared there, but you have a negative number, then that can't be true, but it's a theorem. The fundamental theorem of algebra, which is what algebra is based on, says that it has to be true. And there's a cool video that shows this. If you want to Google it, you can Google imaginary numbers and the fundamental theorem of algebra. Most of you probably won't, but it is kind of neat. And it shows how there's actually, a parabola here, but if you draw this third axis that's coming out at us, then this parabola comes out at us kind of at an angle here. So it's coming this way at us, and it does wind up crossing the x-axis somewhere up here in the sky. Okay, and that would be your imaginary numbers. And you do start dealing with this more in pre-calculus and calculus, and you do add in a z-axis, which is coming out at you. So an imaginary unit I is defined as I equals the square root of -1. So the square root of -1 is always going to equal I. Okay? You have other imaginary numbers. An imaginary number can be written in the form bi. The square of an imaginary number is the original negative number. So I know that's a lot to remember, but we'll take a look at it. So I squared, okay, would be the square root of -1 squared. So that would go away, and you would just get -1. Okay? You don't have to remember all of those. Sometimes, you'll get I to the third, I to the fourth, I to the fifth. As long as you can do this math, you can remember it, but really we're going to be dealing with I squared and I the majority of the time. Okay, so let's actually look at simplifying these. Okay, so 3 is on the outside, so I know it's going to stay on the outside. Square root of -16. Well, I'm going to break this up into a -1 times a 16. I know my square root of -1 is I. And I know my square root of 16 is 4. So the way I'm going to write that is 4i. So this is your b, okay, or your coefficient. It always comes first. Okay, but remember we had that 3 out there, so really it's 3 times 4 times I, because this is 3 times whatever this square root of -16 is. So our final answer then is 12i. Okay, and just like with regular solving rules, if there's already a square root symbol there, we only take the positive. If we're solving and we have to add a square root symbol, then we're going to take the plus and the minus. Okay, now let's look at this one. There's a negative sign out here, so that's going to come down. Okay, but then I have to deal with inside the radical. So the square root of -64 is -1 times 64. The square root of -1 is I. The square root of 64 is 8. So that negative sign, and then I have 8i. Okay, so -8i is my answer. Okay, so whatever's outside the square root sign stays the same. Okay, square root of -8, and you don't have to show me every single step. You can just take, if it's a negative there, you can just say, oh, well, I know that's going to be an I. Okay, I'm just showing you why it works this way. Okay, times a +8, so -1 times +8 gives us -8. Okay, so that's going to be I times the square root of 8. Well, I have to simplify this. So 8 is 2 times 4. 4 is 2 times 2. So I have a pair of 2's that come out and a 2 that stays under. So that's going to be I times 2 square roots of 2. That's not how we're going to leave it written, though. Okay? We're going to change it to bi and then our square roots. Okay? So this square root symbol, anytime you have a square root symbol, remember it's kind of like a variable. It's kind of like an x or a y. Okay, you can only combine like terms. So I can only add or subtract a square root 2 with a square root of 2. Multiplying and dividing is different. Okay? And it always goes at the very end. Okay, so we want to get in the habit of writing it this way. So this would be our real number. This right here is our imaginary number. And then this right here would be our variable, which in this case would be a square root symbol. Okay? Okay, so complex numbers occur when a real number is added to an imaginary number. It takes the form a plus bi. Okay? So when you're looking at this, a is the real part, and bi or b is the imaginary part. So you don't have to put that I in there, and I'm going to show you with this next example why. So b equals the imaginary part. Okay? So it says, okay, what would x and y have to be to make the equation 4x plus 10i equal 2 minus 4yi true? Well, the first thing I'm going to do is find my real parts. So those are my real parts. So I'm just going to set my two real parts equal and solve. So x equals 1/2. Okay? So that's my x answer. Okay, so now I find my imaginary parts, and I set those equal. So 10, and remember, you don't have to include that I, that's just telling us it's the imaginary part. So 10 equals negative 4y, divide by negative 4, divide by negative 4, and you get, oh geez, what is this? Negative 5/2 equals y. Okay? So that's what our x and y would have to be. Our next thing is the complex conjugate. Okay? So anytime we're talking about a conjugate, we're talking about an opposite. So a plus bi, the complex conjugate is always a minus bi. Now sometimes you will see it in the form bi plus a. That's fine, but remember it's complex conjugate. You always change the sign on the imaginary number. That's going to be negative bi plus a. Okay? So you have to pay close attention to that. You always change the sign on the imaginary number. Okay? So this one, find the complex conjugate of each. So 9 minus I, change the sign on the imaginary part, and you get 9 plus I. 2i plus 5, well, here's the imaginary part, so I have to change my my sign on my imaginary part. So it's going to be negative 2i plus 5. Now it says to multiply these conjugates. So I'm going to do the first one. So 9 minus, not 1, 9 minus I times 9 plus I. They're binomial, so I'm just going to FOIL just like normal. So first, 9 times 9 is 81. Outer plus 9i. Inner minus 9i. And then last would be negative I times positive I, which would be negative I squared. Well, now I'm going to combine like terms. You can see that these have canceled. Okay, so now I'm left with 81 minus I squared. But remember, back here, we said I squared is really negative 1. Okay, that is the biggest thing that students forget. So now I'm going to plug that I squared in as a negative 1. Okay, this minus sign is not part of the I. Okay, I squared is negative 1, and that minus sign is still there. So that gives me 82. Okay. And anytime you multiply complex conjugates, this middle term will cancel out. So if I do the same thing there, the middle term is going to cancel out. Okay. Now let's take a look at adding and subtracting complex numbers. So this is the same thing as when we're adding and subtracting regular numbers or variables. Okay, so we're going to pretend that this I is our variable, and we're just going to combine like terms. So 2 plus 4i plus 3 minus 11i. Negative 2 plus 3 is 1. 4i minus 11i is 7, what? Negative 7i. Okay. And that's my answer. Okay, so I've combined like terms. This one right here is subtracting, very important. 4 minus I minus negative 6 plus 2i. Same thing, we're combining like terms, but do not forget to distribute that negative sign. So it really becomes 4 minus I plus 6 minus 2i. Okay, so that's going to be 10 minus 3i. And that's my final answer. Okay, so the I, treat it like it's a variable. Okay, when you're adding, subtracting, multiplying, dividing complex numbers. Okay, so multiplying, same exact thing. We're just going to take this and we're going to FOIL it out. So 2i times 3 is 6i. 2i times negative 5i is negative 10i squared. But here's that I squared again. We know that that's really a negative 1. Okay? So it's 6i minus 10 times negative 1. Okay, those are multiplied. Okay, so it's really going to be 6i plus 10. Okay. So negative 10 and a negative 10. Okay, so I just went on ahead and changed it to a plus. If you're uncomfortable doing that, it would be 6i minus negative 10. And then that would change to a plus. Okay. Here, same thing we did when we multiplied the complex conjugates. Okay, pay close attention, because if there's no sign in there, you're multiplying or dividing. If there is a sign, you're adding or subtracting. Lots of students miss that because they think that this is supposed to be added or subtracted. If there are two parentheses next to each other, it is multiplying. Okay, 4 times 6 is 24, and I'm just FOILing. 4 times negative I is negative 4i. Negative 4i plus 6 is negative 24i. And negative 4i minus I is plus 4i squared. These are not complex conjugates, so this middle term is not going to go away this time. Okay, so now I have 24 minus 28i. Okay, this I squared becomes a negative 1. Okay, so now I'm going to have 24 minus 28i minus 4. And now I can combine these like terms and I get 20 minus 28i. Okay. In this case, anytime I have an I term, okay, it's going to wind up being in its A minus BI form, or A plus BI form. Okay. So if you're adding or subtracting like this, it's going to wind up being in that A plus BI form. Okay, let's go ahead and do the last one. So we're going to FOIL again. Why don't you guys pause the video and try it and see what you get. Okay, so hopefully you tried it. Notice these are complex conjugates. 3 times 3 is 9. 3 times negative 2i is negative 6i. 2i times 3 is positive 6i. So those should cancel, okay, because these are complex conjugates. And then positive 2i times negative 2i is negative 4i squared. I squared becomes a negative 1. So I'm going to have 9 minus negative 4, which is 9 plus 4, which is 13. Okay, and you notice every time I multiply the complex conjugates, I got just a number. Okay, that's what should happen. Okay, so multiply complex conjugates, you get just a number. Okay, and then these should always wind up in their A plus BI form. Okay, A plus BI form. Okay, so 6i plus 10. On your tests, I'll probably say write it in your A plus BI form, so you would want to change it to 10 plus 6i, and that's all you have to do. So that's your A plus BI form, where your imaginary comes second. Okay. Okay, so once again, you don't have to go through every single one of these. I put it on here because the what am I saying? Because the apex goes through it. So I equals the square root of negative 1. Excuse me. I squared is the square root of negative 1 times the square root of negative 1. Or it can be written as negative 1 square root of negative 1 squared, which cancels and leaves you with negative 1. I to the third, you would do the same thing. Square root of negative 1, square root of negative 1 times square root of negative 1. So that's going to be negative, and that's going to be the square root of negative 1. Okay? So we're doing negative 1 times the square root of negative 1. I to the fourth, same thing. Square root of negative 1 times square root of negative 1 times square root of negative 1 times square root of negative 1. Well, we know that this is negative 1. This is negative 1. So that right there is going to be positive 1. Okay? And then these just repeat. So then it goes back to square root of negative 1, negative 1, negative square root of negative 1, positive 1. Okay? And they just repeat over and over again. Okay, but like I said, I and I squared are the ones that you're going to need to know the most. Okay? Dividing complex numbers. Okay? We don't ever want an imaginary number in a denominator. So we always multiply by the conjugate, by the complex conjugate. So if I have a plus 8i, which is what it is, my a value here is 0. So for my complex conjugate, it's going to be 0 minus 8i. So I'm going to multiply by negative 8i over negative 8i. Okay, I am not changing what this function or this equation is. All I'm doing is changing the way it looks. So I'm multiplying by a 1, right? Negative 8i over negative 8i is 1, just to change the way it looks. Okay. So now I'm going to go on ahead and multiply this out. 3 times negative 8 is negative 24i. 7i times negative 8 is negative 56i squared. Okay, and here I'm going to have 8i times negative 8i is negative 64i squared. Okay, so our I squareds become negative 1s. So negative 24i minus 56 times negative 1 over negative 64 times negative 1. This is going to become a positive 56. Okay, so I'm going to rewrite it in a plus bi form. So that's going to be positive 56 minus 24i all over positive 64. Okay, this one you can actually simplify down some. So let's see, these are all divisible by 2. And you get, let's see, 56 divided by 2 is 28. And I might be able to do it again. I don't know. I haven't worked this problem out separately yet. 64 divided by 2. So it looks like I can probably go by 4s. So 56 divided by 4 is 14. So I'm going to just divide everything by 4 and see what we get. Negative 24 divided by 4 is 6. 64 divided by 4. Oh, and look, we could go to 8s even. Okay. Right? I didn't think about that before, but all of these are divisible by 8. Okay, so now I'm going to divide by 8. So I'm going to get 7 minus 3i all over 8. Okay, and that's as simplified as it can get. Oh, sorry, you missed all that. Okay. So I was just seeing what they were all divisible by. Okay, so they're all divisible by 8. Okay, that's our simplest terms, our simplest form. Okay, so same thing here. We're dividing by a 2 minus 4i. Our complex conjugate is 2 plus 4i. So we multiply by 2 plus 4i over 2 plus 4i because it gets rid of the I terms. Okay, so now I'm just going to multiply my binomials. 5 times 2 is 10. Okay, 5 times 4i is 20i. I times 2 is 2i. And I times 4i is 4i squared all over. 2 times 2 is 4. I know my middle terms are going to cancel, but I'm going to go on ahead and show you the multiplying by them anyways. 2 times 4i is 8i. Negative 4i plus 2 is negative 8i, so those are going to cancel. And then negative 4i plus 4i is negative 16i squared. Okay, so our I squareds change to negative 1s, and I'm going to combine my like terms while I'm at it. So 10 plus 20i plus 2i is plus 22i, and 4 times negative 1 is negative 4. And then I'm going to have 4, negative 16 times negative 1 is positive 16. Okay, finish combining. 10 minus 4 is 6, plus 22i all over 20. And now all of these are divisible by 2. So that's going to be 3 plus 11i all over 10. Okay, make sure you write it in simplest form or you will lose credit. Okay. Okay, and then we have 3 minus i over 2 minus i. Okay, so we got to get rid of this 2 minus I, so we're going to multiply by that complex conjugate, okay, over itself, and multiplying by 1 because we can't change this equation. We're just changing what it looks like. Okay, so 3 times 2 is 6. 3 times I is 3i. Negative I times 2 is negative 2I. And negative I times I is negative I squared. All over, 2 times 2 is 4. I know these middle terms are going to cancel, so I'm just going to go on ahead and multiply my last terms. Negative I times I is negative I squared. Okay? So I just skipped multiplying my outer and inner, because I know they're going to cancel. Okay, so now I'm going to have 6. 3I minus 2I is plus 1I, and negative I squared is negative times negative 1. Okay. 4 minus I squared is 4 minus negative 1. Okay, so now I'm going to have 6. This becomes a plus, so 6 plus 1 is 7, plus I, all over 4, plus 1, which is 5. Okay. So imaginary numbers, okay, they're kind of like variables. Okay. The most important thing to remember is I equals the square root of negative 1, and I squared equals negative 1. Okay. I squared is the most forgotten thing when you're multiplying and dividing, okay, complex numbers. And then, like I said before, the other thing that I see the most is that students either miss the addition or subtraction sign, or they think there should be an addition or subtraction sign. Okay, so don't get addition and subtraction mixed up with multiplication. See you guys next time.